Although containers are a very efficient abstraction, anybody who uses them still needs a scalable way to run them and manage them. For its own internal operations, Google built a cluster management, networking, and naming system to allow container technology to operate at Google scale. It built on what it learned to create Kubernetes, and it has offered Kubernetes to the world as open source. Many Google customers have told us that they want to work in a multi-cloud world. The portability of containers, plus the open source nature and management capabilities of Kubernetes, have combined to make it a leading technology for building that world. Kubernetes builds on containers to create a more general concept of a pod. Let's say you built a new web chat application. You'd like to equip your application with logging. One of your coworkers is building a nice logging subsystem, but she's doing that with her own development tools. So you package your application in a container, and she packages her logging subsystem in another container, and then you deploy them together in a Kubernetes pod. This way, your application always has access to logging at a known endpoint. Kubernetes runs in many environments, from your laptop to major cloud providers, GCP and others. The Kubernetes API is completely open, and the whole system is modular and replaceable. Kubernetes doesn't force applications to know about aspects of their environment that are cloud provider specific, such as what the network looks like, what load balancing is in use, and how persistent storage volumes are built. That makes it much easier to build once and deploy anywhere. After your application is deployed on Kubernetes, you can perform a rolling update, which incrementally replaces your resources pods with new ones, which are then scheduled on nodes with available resources. Rolling updates are designed to update your workloads without downtime. So what exactly is a Kubernetes cluster? It's a group of machines where Kubernetes can schedule containers. Those machines are called nodes. Clusters can have nodes spread across zones to give greater resiliency. Kubernetes has a built-in scaling and load balancing capability. External traffic to your application running in Kubernetes gets routed to the ingress port you specify, and Kubernetes can automatically scale your application as the incoming load changes.